In this video, I wanted to go over an example problem involving simple harmonic motion. Be sure to watch my previous video for an overview of the formulas commonly used in solving simple harmonic motion problems. Here we have a problem where we're told that the displacement of an object is described by the following equation, where x is equal to 0.25 meters multiplied by the cosine of 7.0 times time. You're asked to determine the amplitude, the frequency, the period, the maximum speed, and the maximum acceleration of the object. In my previous video, I mentioned how the displacement in simple harmonic motion can be modeled by the following equation. Here the displacement, or x, is equal to the amplitude multiplied by the cosine of 2 pi times the frequency times time. Here 2 pi multiplied by the frequency is simply the angular velocity. Looking at the equation that we were given in the problem, we should now be able to extract some useful information. For example, we can now easily see that the amplitude is just 0.25 meters and that the angular velocity is equal to 7 radians per second. We have now found the answer for part A, and we can just say that the amplitude is equal to 0.25 meters. For part B, we can use the fact that the angular velocity, or 2 pi times the frequency, is equal to 7 radians per second. Because radians are a dimensionless quantity, we can just write 1 over seconds, or seconds to the negative first power. We can divide by 2 pi to find that the frequency is equal to approximately 1.11 hertz, or cycles per second. Because period is just the reciprocal of frequency, we can divide 1 by the frequency that we just found to find that the period is equal to approximately 0.90 seconds. For part D, we know that the maximum velocity in simple harmonic motion can be found by multiplying 2 pi by the amplitude and the frequency. Substituting in the values from parts A and B, we can find that the maximum velocity is equal to approximately 1.74 meters per second. Now we just need to find the maximum acceleration in part E. From Newton's second law of motion, we can say that the maximum acceleration is equal to the maximum force divided by the mass. We know that the force will be equal to the spring force, which is the spring constant multiplied by the displacement. Because the amplitude is the maximum displacement, we can say that the maximum acceleration is equal to the spring constant multiplied by the amplitude divided by the mass. In my previous video, I showed how the frequency is equal to 1 over 2 pi multiplied by the square root of the spring constant divided by the mass. Squaring both sides and rearranging to solve for k over m, we can say that the spring constant divided by the mass is equal to the square of 2 pi times the frequency. If we plug this into our equation for the maximum acceleration, we can see that the maximum acceleration is simply equal to the square of 2 pi times the frequency multiplied by the amplitude. Plugging in the amplitude and frequency we found in parts A and B, we can find that the maximum acceleration is equal to approximately 12.16 meters per second squared. We have now solved for everything that the problem asks for. I hope that this video was helpful in demonstrating how you can solve simple harmonic motion problems using the formulas discussed in my previous video. If you still have any questions on this topic, feel free to comment below or visit fastphysicshelp.com. If you found this video helpful, please give it a like and consider subscribing for more fast physics videos. Thanks for watching.